Hello, you're welcome back. All right, still on algebra, right? So the revision questions that we're going to be looking at in this video is change of subject formula questions. All right, we are going to be solving the question on change of subject formula. All right, so there is a lot of this question. Hopefully, okay, solving all of them will actually take care of every aspect of a change of subject formula, right? Okay, so now let's start with the very first question here. So the question goes this way: make Q the subject of the formula when L, all right? So the expression is L is equal to 4 all over 3. And of course, there's the square root of PQ. All right, so you know very well that for you to actually express a particular um, variable as a subject, okay, first of all, you have to find out if there's any kind of function that is restricted that variable from being transferred to the order to the left hand side of the equation, because making Q the subject of formula is the same as expressing Q, all right, in terms of order. That means to make Q the subject of the formula simply means that this Q is supposed to be exactly where this L, all right, then L will be uh, uh, at the right hand side, okay. So but I cannot actually move Q to anywhere in as much as I have Q being inside the square root, okay? So anytime you're being asked to make a particular variable a subject of the formula of any expression, check, all right, if there's a kind of restriction, all right, in form of square root, cube root, square, whatever, all right. So for you to actually remove that restriction, you use the opposite of that particular mathematical operator. What I have here, all right, is a square root. PQ is found inside the square root. And for me to be able to eliminate square root, I will use square, all right? So for me to eliminate the square root, I will use square. So what I would do is to square both sides. Square both sides. Because I know very well that square will definitely cancel square root. So I'll square both sides. So I have to square L. That's going to be L square. I'll have to square 4. If I square 4, I will have 16. If I square 3, I will have 9. Then squaring the square root of PQ. The square cancels the square root. So PQ now, all right, is written without the square root. Okay, so that's the very first step. Now the next step is to uh, cross multiply, or better still, okay, you have to, if you want to eliminate, you want to remove this 9 as the denominator, all right. I don't want to have a fraction, okay. So what I would do, all right, in most cases I love cross multiplying, okay. I will love cross multiplying since what I have, all right, both sides of the equation are single fractions, so I have to cross multiply. So cross multiplying, I have 16 PQ multiplied by 1 will give me 16 PQ. Then 9 multiplied by L square will give me 9 L square. So that way now I can now divide both sides um, by 16p to be, because I'm looking for Q. So I have to eliminate this 16p, all right? So if I divide both sides by 16p, 16p cancels 16p, I will now have Q to be equal to 9L square, of course, divided by 16p. Okay, so as simple as that. All right, here we go. Next question. Okay, so this time around we have to make R the subject, and all right. In this case also, R is found inside a square root. R is found inside the square root. So I have to square both sides. So the very first step is to square both sides. So that's going to be p squared. And of course, it's equal to, if I square the square root, all right, of r s cube all over t, square cancels square root. So I'm having r x cube. Then, of course, divided by t. So you know what I'm going to do next. Okay, the next step is to cross multiply, cross multiply. Okay, if I'm cross multiplying, rx cube multiplied by 1 will give me rx cube equal to, all right, then I have p squared t. Of course, you know very well now, for me to be able to, all right, get my r is going to be equal to p squared t, of course, divided by x cube. As simple as that. Okay. All right. So next question. Here I'm to make a cue the subject. All right. Solution. So I have P is equal to, okay. So in this case, you know exactly what I'm gonna do. But let me write down the question first. I won't cross multiply at this point. I will tell you why I won't cross multiply, okay? Because of this plus 1 right here. I can only cross multiply if there's no plus 1, all right? Because that will actually, um, if there's no plus 1, this will be a single fraction that can easily cross multiply. So since there's a plus 1, in this case, I won't cross multiply. The only way I can, if I want to use if I want to cross multiply, right? If I want to use the method of cross multiplying, all I just need to do is to simplify this fraction at the right hand side so that I will have a single fraction with a single denominator. All right. So before I cross multiply, but since I may not want to go through that route, okay, it's kind of longer. So anytime you see a situation where you have one fraction, all right, where the fraction is connected with another expression plus 1 or whatever, that's an addition, all right, what you do is you multiply through by the LCM of the denominator, all right? So the denominator I have here is 5. So I'm going to multiply everything, multiply through by 5. All right. So if I have another denominator here, I would have found the LCM. But since the denominator that I have here is 5, or of course, you know that all this is all over 1, this is all over 1. You know that already. Okay. So now, so this is going to be 5p. All right. So of course, 5 times, if I multiply 5 right here, 5 will cancel 5. So I'm left with x plus q. Of course, 5 multiplied by 1, I will have 5. So since I want to make you the subject, I have to open this bracket, right? So this is going to be 5p. Opening this bracket, I'm going to have mx. Then, of course, plus mq. All right, then plus 5. Of course, you know very well that what I'm going to do here now, I have to rearrange the equation, okay, so that mq will just be at one side of the equation, okay? So I'm going to move mx plus 5 to the other side. So, okay, so here I'm going to have this mq, right? So 5p, I'm going to move it mx to the other side. Ms is plus, it goes over, it becomes minus mx. Plus 5 is plus here, it goes over, it becomes minus 5. So as a matter of fact, my q now is going to be equal to 5p minus mx minus 5, then of course divided by m. All right. So that is the answer. All right, then we proceed. Okay, so This is also similar question to what we solved previously. Okay, you know what we do first? We square both sides. Square both sides. So I'm having r square. Of course, if I square that square root, the square root will cancel this. The square will cancel the square root. So I'm left with 3v all over pi h. All right. So, all right. And of course, you know, at this point now, since I'm having a single fraction at the right hand side, I can cross multiply. All right. Okay. So by cross multiply, you know this is all over 1. Cross multiply, and I'm going to have 3v multiplied by 1. That's 3v. All right. So pi h multiplied by um, r squared, that's going to be pi r square h. So with what I have now, I can get my v. My v now is going to be equal to pi r square h, of course, divided by 3. All right, so the last but not the least, okay, so solution. Now, in this case, you know exactly what I'm going to do. Since I'm making x the subject of formula, I have to cross multiply. If I cross multiply, so let me cross multiply. So by cross multiply, I'm going to have y multiplied by 4x. That's going to give me 4xy. Y multiplied by 5d. That's going to give me 5dy. And of course, you know that this all over 1, right? Is equal to 3x multiplied by 1 will give me 3x minus 9c. So since the x, all right, is not just in one place, the x is found both sides of the equation. So what I will do is to collect like terms, CLT, I'll collect like terms. So every term that has x, I'll bring it to one side of the equation. So I'm going to have 4xy. I'll move this 3x to this side of the equation. I'm going to have minus 3x. Okay? Is equal to minus 9c. I'm going to have move this plus 5dy to the other side. That's going to be minus 5dy. All right, so now how do I take out x? X is a common factor for these two expressions. So since I want to make it the subject, I have to take it as a common factor, take it out. All right, so inside the bracket, I'm going to have 4y and of course minus 3 is equal to minus 9c minus 5dy. Okay, so of course, at this point now, you know very well that x now is going to be equal to minus 9c minus 5dy, then all divided by 4y minus 3. Now, the answer will not actually be expressed in this form. All right, the answer will not be expressed in this form. Okay, so in most cases, you're going to see since I have common minus at the numerator, I'm going to take it out as a factor. So you see something of this, you may see something of this. Minus is taken out, all right? So I'm going to have 9c. Of course, you know minus into minus is plus, right? Plus, since minus is outside, right? So this one I'm going to change it to plus. So this is 5dy. Then, of course, divided by 4y minus 3. So if you don't see the answer in this form, all right, in the objective or options, then you will see it in this form. All right, so I hope that is well understood. Okay, so we are going to look at more in the next video. See you in the next video. Thank you very much.